When you learn statistics, there is new terminology to know. Now, many of these words may be words that you already know, but I am going to be using them in a specific way. And you, as a critical thinker, want to know what I mean when I use certain words. So, I'm going to tell you. We have already learned that statistics provide a way for us to evaluate claims of truth, like mind reading, or knowing what card you picked. I may claim that I know what card you picked, and I may tell you to trust me, but you know better. And by the way, never trust somebody who says, trust me. Trustworthy people never tell you to trust them. They just do the things that trustworthy people do. The ones who have to tell you to trust them are the ones you should keep a very close eye on. So along the way, I'm going to be telling you lots of things about statistics, and I promise you that I am going to do my best to get it right. But if at any time you have questions about what I tell you, if you need more explanation, or you think I may have gotten something wrong, you are free to ask me for evidence or an explanation. That's how we do science. If I really do know what I'm talking about, then I should be able to explain myself and answer your questions. So, since I think I know what I'm talking about, you should never be afraid to ask questions. So let's learn some new words. This thing that we do in science is called research. Research refers to procedures for organizing data to better understand the world and to evaluate claims of truth. We collect data about the world. Data are the scores obtained in research. The word is actually the plural of a word, datum. So we say the data are rather than the data is. We take what we learn from the data and use it to better understand the world. We tell stories with data. Now, data are facts, so data cannot be copyrighted. On the other hand, presentations of data, such as that journal article that you wrote, can be copyrighted. We analyze our data to tell our stories to better understand the world using statistics. Doing statistical research involves collecting, organizing, analyzing, and interpreting numerical data. Collecting, measuring or quantifying the world. Organizing, structuring data to understand what they mean. Analyzing, interrogating the data to find out what they reveal about the world. Interpreting, telling the story that we learned from the data. Statistics are the point at which common sense meets logic, where numbers are used to convey ideas. That means that someone else could use your data, reanalyze it, and write their own article confirming or critiquing what you wrote. Does your narrative hold up? In science, we should be making our data available to other researchers because we want more people to look at our numbers and so to advance the field. The word statistics may refer to three things. Number one, the practice of doing statistics, the field or discipline of using math plus logic to make sense of data. So you are taking a statistics class where you will learn about this field. I am a statistics teacher. You are a statistics student. We are studying the application of statistics. 2, statistics may refer to the mathematical procedures that we use to organize, summarize, and make sense of our data. We will learn how to do t-tests and correlations. We will learn how to do statistics. 3, statistics may refer to the numbers obtained from the statistical procedures, such as means, standard deviations, or correlation coefficients. We might ask, what are the statistics on gun violence in America? And we want to know how many people are killed by guns every year in the US. Then we could compare those statistics to other countries and ask if the same pattern holds true in other countries. And if not, why not? What are they doing differently? And let me be even more specific about the term statistics. Those means, standard deviations, and other numbers are properly called statistics when they characterize data from a sample. You see, we almost never study the whole population of all possible people who might be included. Instead, we study a smaller subset of those people. That subset is called a sample, and the numbers that we calculate about our sample are called statistics. If we were to measure the entire population, calculate their mean and standard deviation, then we would call those numbers parameters. Parameters are numbers that characterize data from a population. In order to be clear, whether we are talking about statistics or parameters, we use different letters to describe them. Statistics tend to use English letters, M and SD for mean and standard deviation. Parameters tend to use Greek letters, like sigma, mu, psi, or lambda. So the mean of the sample would be M, but the mean of the population would be mu. When we are using a sample that has been drawn from a population, we call those techniques parametric statistics because they use population values. We will learn about other tests, like the chi-square, that do not rely on population values, and we will call those techniques non-parametric statistics. Another way to describe statistics is to separate them based on what they do. We call them descriptive or inferential statistics. Descriptive statistics are procedures that organize and summarize a large amount of data, like the mean or the standard deviation. Descriptive statistics are used to interpret and describe the important characteristics of the data. They can simplify millions of numbers into a single number that can be used for comparisons. Examples of descriptive statistics would be mean, median, mode, average, standard deviation, or graphs. Inferential statistics, on the other hand, are procedures that are used to draw conclusions about data and to make inferences, or educated guesses, or predictions about values that are unknown. So if I draw a sample of people from a population of people who eat a lot of bacon, and then I draw another sample of people who are vegetarians, and maybe a third sample of people who eat bacon but very rarely, each of those samples will have an average blood cholesterol. If I follow them long term, each sample will have a certain number of people who die from heart disease or cancer. I can use inferential statistics to infer whether bacon consumption is related to cholesterol, heart disease, or cancer. An inference is a conclusion reached on the basis of evidence and reasoning. I might ask you to look at the data and say whether you infer that any differences in health outcomes were due to random chance or due to the effect of bacon consumption. Infer is different than imply. If you suggest that a difference in health outcomes might exist, then you imply there is a difference. If I pick up on your suggestion and say, well, based on what you show me, I'm going to make some changes in how I eat, then I infer what you implied. When we are doing inferential statistics, we look at the data and infer from the data something about the population.